And welcome students to our new unit on electronic components. Today we get to discuss what is a breadboard. Alright, so let's get started here. Breadboards are one of the most fundamental pieces when it comes to learning how to build circuits. This right here is a picture of an example breadboard. We are actually going to be working with our own breadboards in this unit, and it's all part of our whole bigger unit on basic circuit boarding. So why use a breadboard? All right, and when we're talking breadboards, I'm not talking about the thing that you put a loaf of bread on and cut on. No, I'm not talking about that. Instead, this is an electronics breadboard that actually refers to what's known as a solderless breadboard. These are great units for making temporary circuits and prototyping, as they require absolutely no soldering. And if we had to solder, we'd have to get a soldering gun. We have to work with that. We have to learn how to properly handle and work with all those different components. But we're going to mostly use approaches from a solderless approach. Now, breadboards are the best place to start for those that are new to circuitry, as they can range from something very simple to quite complex. So here's a quick anatomy of a breadboard. Right? There's just some quick examples here. So sample breadboard, and as you can see, we have power rails, we have some terminal strips, we have dip support, and binding posts. Now, you may not always have binding posts. In fact, on the ones that we're going to work with, we won't have binding posts, simply because we're going to be hooking ours up to an external device. So, these are components, and so let's start with the first thing, which are the terminal strips. All right, now this is an example of another breadboard right here, and this is without the adhesive on the back. So this is kind of what it looks like on the back side, is with these little metal prongs here, which of course you can see. If you actually to open these up, they actually look a lot more like this. They're kind of in these little rows of 5. All right, here we have a breadboard, like I said, where the adhesive backing is removed. You can see lots of horizontal rows of metal strips in the bottom of the breadboard. Now, the tops of the metal rows have little clips that hide under these plastic holes. These clips allow you to stick a wire or the leg of a component into the exposed holes of the breadboard, which then will hold in place. So these are like little clips. So you stick the wire in there and clip, and it's locked in. Right. Now with the terminal strips, once inserted, that component will be electronically connected to anything else placed within that row. This is because the metal rows are conductive and allow the current to flow from any point in the strip. Notice that there's only about 5 clips in the strip, which is typical on almost all breadboards. Thus, you can only have about 5 components connected in one particular section of the breadboard. The row has about 10 holes, so you might wonder, why can you only connect 5 components? You also notice that each horizontal row is separated then by a ravine or a crevasse in the middle of the breadboard. This ravine isolates both sides of a given row from one another, so they are not really electronically connected at all. Power rails, which are, of course, these things here along the side of this breadboard. So if you were giving power, they'd be along the side. These power rails are metal strips that are identical to the ones that run horizontally, that we saw on the back of the terminals there, except these are typically all connected. When building a circuit, you tend to need power in lots of different places. So the power rails give you lots of easy access power whenever you need a circuit, so you don't have to try and daisy chain out to someplace else. It's all right there. Now, usually they're going to be labeled with a plus or a minus, indicating positive or negative, and have a red or blue stripe in order to indicate the positive or negative side. Still talking about power rails here. It's important to be aware that the power rails on either side are not connected, right? So this power rail has no way of connecting to this power rail. They're totally separate from each other. So if you want the same power source on both sides, you will need to connect the two sides with some kind of jumper wire, as shown up here. So you have a red and you have a black, so that's your positive and your negative. So that's how you connect those. Now, keep in mind that these markings are typically just there as a reference. There's no rule that says you have to plug into the positive rail and the ground on the minus rail, though it's good practice to keep everything over. So you don't have to necessarily plug this positive in here and this positive in here. You could have it go anywhere that you really want, but typically, like if you notice, you see like 5 and 10 here. If you plug it in at 5, you probably are going to plug it in on 5 on the other side as well, just so you can kind of keep track of which one corresponds to which. All right, next is dip support. Earlier we mentioned the ravine that isolates the two sides of a breadboard. This ravine serves a very important purpose. Many integrated circuits are manufactured specifically to fit onto breadboards. In order to minimize the amount of space they take up on the breadboard, they come in what is known as a dual inline package or DIP. Alright, so DIP support, there's, like I say, and there's this little ravine. This is like this little, almost looks like a split down the middle of a breadboard. That is that ravine we're talking about there. So these dip chips have little legs, and you can kind of see it here in this diagram. These little like metal legs coming out here almost makes it look kind of like some kind of a metal caterpillar. And they tend to fit perfectly over that ravine. Since each leg on the IC is unique, we don't want both sides to be connected to each other. And that's where the separation in the middle of the board comes in handy, because we don't want them to accidentally touch each other. Thus, we can connect components to each side of the IC without interfering with the functionality of the leg on the opposite side. Alright, rows and columns, which I kind of have already alluded to. You may find that many breadboards have numbers and letters marked on various rows and columns. These don't serve any purpose other than to help guide you when building your circuits. Now, circuits can get complicated very quickly. Right? And all it takes is one misplaced leg of a component really to make the entire circuit malfunction or really not work at all. It's very easy to do. So again, keeping to using those numbers, even though yes, they're there as guides, you don't have to follow them. It's best practice to really kind of follow them because it makes it a lot easier to come back and troubleshoot. Just like for anyone that's done coding, we have the lines of code there are typically in like an IDE, like let's say for those that do Java programming, use things like, for example, Eclipse, and they will have numbers along the side to help you troubleshoot what line of code might be causing you issues. Now, if you know the row number of the connection you're trying to make, it makes it much simpler to plug a wire into that number then, rather than eyeballing it. It's like, well, it looks like it's about 4, so I'm just going to plug it in at 4. Well, if it's not actually at 4, and it was actually at 3, obviously I know those are pretty easy numbers to count down from. Like if it, as like I'm saying, it was like at 12, which might be a little bit harder to find. But it kind of gets the point across. If it's actually supposed to be at 4 and you plug in at 3, you could run into some issues. All right, providing power to a breadboard. I've already talked about this. You can, of course, have terminal connectors, which accomplish, and I could talk about that. But since we're not going to be really working with terminal connectors, I've opted to kind of take that piece out because instead what we're going to do is be working with an Arduino. All right, and since we're working that, it typically will get its power from USB. Now, with USB, you can simply pull power from the Arduino's female headers. All right, kind of like as you see here in this image here. You just simply plug a cable in and off it goes. Now, the Arduino typically has multiple power and ground pins that you can connect to the power rails or other rails or rows on the breadboard. So you're kind of like power goes to the Arduino gives power to the breadboard makes stuff happen. And that's where we're going to kind of wrap it up for today, folks. I'm really excited to get into this unit because I know we spent quite a bit of time on hardware. So when we come back next time, we're going to talk a little bit about some electronics, and then after that, the next lesson is actually start looking at the different components that we're going to be working with. So until then.